Hey guys, so in this video, we're going to be seeing 5 use cases of AI research and development that actually make money. So let's get to it. First, let's quickly clarify what is AI research and development exactly for businesses. So when we hear the term research and development, many people could think about scientists in a lab wearing their white clothes and so on, and maybe some expensive projects that only OpenAI and Microsoft could do. So yeah, it's actually much simpler than that. AI research development is first about identifying an ideal desired outcome. It could be about increasing the sales, increasing the margins, saving time, and so on. And then after that, it's about applying cutting-edge AI to the unique processes of a business or their unique data, so that this business will gain a competitive advantage. It's basically about helping businesses own intellectual property. And the word research in research and development actually mean that we will be following an iterative process. And I listed here all the phases. It always starts with data collection and cleaning. So it's about gathering the data, making sure that it's a high quality data, applying some quality assurance, getting insights from the data, getting rid of any anomaly that we could detect, and so on. And then it's about AI model training. So we'll choose the right machine learning and AI models to train, and then we will do a performance testing. Basically, we'll be evaluating these AI models, whether it is accurate or not. The iterative process is about doing those 2 steps again and again until we find a super accurate model. And then once we are happy with the results, we do a final evaluation. And finally, the development, in research and development, it means that we make the research outcome usable in the real world. Because at the end of the day, we're not doing research just for the sake of research. We want concrete, tangible, real business outcome. So basically, we'll integrate all those models in a business workflow in a seamless way. Because at the end of the day, we want to inform decisions. For example, we'll answer questions like, how many items of this product should I buy for my inventory? Or to which user should I offer a discount before he cancels his subscription? So for example, this integration, this development for the second question could be an automatic email alert to admins of like a SaaS company, so that they will reach out to those clients and so on and so forth. Now let's go through the AI research and development use cases. The first one is about churn prediction, and this concerns a lot of companies out there. Pretty much every single company that relies on a subscription-based either service or product, they will rely on this because they don't want people to cancel their subscription, right? They want to keep increasing this monthly recurring revenue, right? Here I wrote a concrete example. So let's say you run a paid school community where members pay $119 per month. As you might know, School is a website where people can create their community. They can offer courses, but they can also, gatekeep it behind like a monthly fee, so that people can pay, to access that content. And also you have everything related to gamification and so on. I took as an example this school community, which is called Zero to Founder by this guy. And as you can see here, they have 1,900 members who pay $119 per month. I mean, it's not always true, that they all pay this amount of money, because most likely when you start a community, you will start with the lower monthly fee. For example, I don't know, $60 per month. And then the more members keep coming, the more you will keep adding, this monthly fee. So let's say, just for simplification purposes, that all of them paid or are paying $190 per month. And let's also assume that this school community have a 15% churn rate, which means that every single month, 285 members leave the community. which means that if we multiply 285 by 119 every single month, this code community with this churn rate would lose $33,915, basically almost $34,000 from just members canceling, basically. And the problem is that you don't know who's next, and you don't really know why people churn. So we will focus on this question. For using AI, we can answer this question: who's next? Why people churn? It's a bit more advanced. It touches upon a subfield of AI called explainable AI. In short, it's XAI. So, but yeah, for this use case, for this video, we'll be focusing on this. So the first step will be to collect historical data about each member. I don't know right now if School is providing an API to get this data, but even if it is not the case, we can still do it via web scraping. So for each user, we will collect a lot of data. So for example, here for this user, we will collect the number of points to level up, his current level, his bio, when did he join, his country, the number of contributions, the number of followers, how many people is he following, and so on. We will also see if we can collect the course completion rate and the content unlocked to price ratio. So yeah, this could be very interesting data to feed to the AI so that it will guess more accurately which users are more likely to churn next. Then we can collect more information about the user activity. So first, his source, from where did he start the subscription? Is it from YouTube, from School Explorer, from Reddit, and so on? His login frequency, is it daily, is it monthly, and so on? The time spent per session, the number of posts that are read or created, the number of comments or likes, his participation in Google Meet events, and so on, and the days since last activity. We can also inform the AI about everything that is payment related, like how much did he pay? How much is he paying currently? The payment method, because maybe the people that pay via PayPal will more likely churn than the people that pay directly with their credit card, right? We can also collect the number of billing cycles completed, right? Or if he did some upgrades or downgrades during his subscription. Then we will take all this data and we will massage it, we will process it. So for each customer, past and present, we will add a churn event, 1 if he has churned, 0 if he has not. And also we should avoid something in machine learning called temporal leakage, meaning that like if a member churned and some interaction from him happened after the churn, we should not include this data that concerns this user, because we don't want the AI to access something from the future, we just want, because at the end of the day, what we'll be doing is about making the AI make predictions. And if we teach it something from the future about each user, the end results will be very bad, right? And what we usually do for those projects, it's about splitting the data into 3 parts. 60% for training, 20% for testing the AI, and the 20% left for validation. And this data needs to be in chronological order. So let's say we have all these data sets from past and present clients from January up to August. We could use, for example, January up to May in training, June up to July in testing, and finally the data of August for validation. And as pretty much many machine learning projects, we shouldn't reinvent the wheel. We should not come up with a new AI model and then train it and so on. We should just see what other people did successfully and then adapt it to our use case. So the first thing I will do is go to Google Scholar and then here, just type churn prediction machine learning. So here, as you can see, you have a paper from 2022. It's a bit old, where the title is Customer Churn Prediction System, a Machine Learning Approach. So we could download this PDF and see what those researchers did and what were the results, right? We can also, so we have this paper, a comparison of machine learning techniques for customer churn prediction. This is already good, but it's a bit old, you know? We can filter the results and get only from 2024 onwards. Here you can see, a paper that seems very good, a review on machine learning methods for customer churn prediction and recommendations for business practitioners. Yeah, this seems very good. If I had this type of project, I would likely download this PDF and read it and understand what are the best practices, basically. Another nice source of best practices is this website, Kaggle. It's about data science competitions and projects. And here, as you can see, I just searched the term churn prediction, and then we can see a lot of projects. So, for example, here it's about bank churn data exploration and prediction. Here it's about a telecom company, and so on. So you can see you have so many nice posts and what people did, and you can just reuse what people did, but then adapt it to a specific data set. The next step will be, of course, about training the machine learning models and select the best one in terms of performance. And then finally move on to the development phase. So basically it's about, as I said previously, making it actually useful for the business now that the model is able to predict which members are going to churn. And let's say every single Friday, the AI model will analyze current members' data and flag the ones who are likely to cancel their subscription. And we could trigger some event on top of that. For example, the AI could send an alert to the admin so they can send a DM, or maybe even offer a discount on next month, or a free coaching call to keep them from canceling, you know? So this is a very good use case that many businesses out there could benefit from. The second AI use case is one that is dear to my heart because I like forecasting. I like, trying to predict the future, and I'm actually kind of obsessed by it. And actually machine learning can help us do trading via weather forecasting. So weather forecasting is used a lot in agricultural commodities. It's about buying some contracts called futures contracts. So it's about, trading corn, wheat, cotton, coffee, sugar, anything that is agricultural. And let me show you an example of futures. This is corn futures, and I don't want to go into too much details about how it works, but imagine that as like just a stock, where the price is varying, and we want either to buy low, sell high, or to sell high and then buy low, basically. Another one is about the rice futures. So as you can see, those are the prices. And I noticed right now there is something very weird going on, because as you can see, there is like a huge decrease in the price. I don't know what's going on. Like from 1090 here up to 10.96. So yeah, if there is a trader watching this video, make a comment please and tell me what's going on here. So basically the yields of crops, meaning how much trees will produce in terms of fruits and so on, is heavily affected by the weather. If you have, a dry season, obviously you will not produce as much. If you have like a season with a lot of rainfall, maybe it will damage, the crops and so on. And then obviously the yields have an effect on the supply and demand. For example, in the Indian rice, if let's say one season it was super dry, meaning that the production of rice was not that much, right? it means that the supply of rice will decrease. It means that the price of rice will increase by a lot, right? Because many people will want to buy that rice. And if you can know in advance, if there will be more rain in an accurate way, you will gain an edge on the market, and then you can place bets. So here, going back to the rice example, if we are here, right, and then we predict that here the season will not be good for rice, and most likely the rice production will decrease significantly. We will bet that the price of rice will increase, right? Because, as I've just said, the demand will explode. So we can buy and then here wait for the price to start decreasing, right? And then we can sell maybe here and something like that, and we'll make this profit. So of course I'm like summarizing and simplifying a lot. Of course there are so many details that I could talk about in another video. But yeah, if you want like a video about algorithmic trading using weather forecasting in depth, using some machine learning, Python libraries and so on, feel free to comment that. I will be super happy to cover this. And the process will be more or less the same as the first example. It will be about gathering historical data. For example, we can gather the temperature, the rainfall, the humidity, the wind speed, and so on. And you have multiple data sources across the world. You have, for example, this US agency called NOAA, so National Oceanic and Atmospheric Administration. They basically launch a lot of satellites around the world, which capture data about the precipitation, the wind speed, the temperature, and so on. And they make this data available to anybody. So anybody can download it and try to make weather forecasting. You also have this website called meteostat.net. I think there is an API with this website where you can fetch data. And as you can see here, for the city of San Diego, we have access to many types of data like the temperature, the wind speed, the air pressure, the precipitation, and so on and so forth. Then the next step would be about feature engineering. This is a step that is super important in a machine learning project. It's about selecting the inputs that are likely having a good impact on the accuracy of the AI models, because some inputs might be super useful for the AI model to make more accurate predictions, and on the contrary, you could have some inputs that actually affect in a very negative way the accuracy of your AI models. And then we do model selection, and obviously we go through the loop of training, comparison, evaluation, and so on. And then finally, when we have accurate forecasting, we move to the development phase, which is the actual interesting part. Because we will be turning knowledge into positive financial outcome. So here I wrote like a concrete example. Let's say we predict that in Brazil, there will be a decrease of rainfall next season in comparison to the normal amount of rainfall. And you know that Brazil produces a lot of coffee around Sao Paulo and other cities. And if there is less rainfall in Brazil, it means that Brazil will produce less coffee, right? And if the supply of coffee decreases, it means that the price of coffee is expected to increase. So we should buy coffee futures because their price will increase, right? So this is basically how to use that edge on the market to place bets so that we can make future profits, basically. Moving to our third example, a RAG AI system for a bank. So as a short reminder, RAG stands for Retrieval Augmented Generation. It's a way to retrieve information using data from your own business using large language models like ChatGPT and so on. Think of it as the AI brain of your business. So let's say you have loan officers working at a commercial bank, and we want to make a RAG to analyze loan application folders. So this system will go over the client history, the past contracts, the collaterals provided by the client, and so on. So the business outcome is super simple. It's about the ability to handle more client applications with the same team. In short, you don't need to hire while you can accept more clients. Because before the RAG, let's say the loan officers could process a maximum of 20 applications per month, and then the bank needed to hire new loan officers if they had an increase of applications, right? But after the RAG, the loan officers can process up to 35 applications per month. So basically, you have a direct increase in profit margins for a bank. And this type of system is ideal for businesses who get new clients on a daily basis, but want to grow while being as lean as possible without hiring, basically. And the process to achieve this will be about gathering past applications. We need to know the type of documents to be processed, what kind of information to extract from those documents, where to write this information. Is it in a Google Sheet online? Is it in like internal CRM and so on? And then we need to build a solid evaluation data set. So all those past applications, we need to, for each application, write what is the outcome. Do we accept it? Do we reject it? If we reject it, what is the reason? And so on and so forth. And then we need to build multiple RAG pipelines so that we'll compare them in terms of 3 metrics, which is the accuracy, the speed, and then the cost per query. And of course, at the end, we'll choose the RAG pipeline with the best trade-off from those 3 metrics. And then once we are happy with the results, we can deploy the system in the bank's software. Our 4th AI research and development use case is about AI for predictive maintenance. So what is predictive maintenance exactly? It's about using AI models to detect when something is wrong or detect an anomaly with a machine, and basically that this machine should be checked. So basically you have 2 types of predictive maintenance. The first one, as I just told you, is about detecting an anomaly, right? And the second type of predictive maintenance, which is more advanced, is trying to predict when a machine is likely going to fail, basically. So for this example, let's just focus on the anomaly. And by the way, one thing that you could think of is, hey, but why do we need AI and machine learning for detecting an anomaly? We already have sensors in a car, for example, that will show you that something is wrong. But the good thing with AI is that it will detect this anomaly way before, the actual sensor detects it, right? Because the AI can detect some micro variations of sensors or vibrations, right? And then tell you, hey, this is weird. This vibration is weird. It doesn't happen normally in a normal state. Right now, this is an anomaly, right? And this concerns any high stakes machines. It could be machines inside a factory. It could be simply cars or trucks or robots or even wind turbines. Basically, any type of machinery. And you need to know that before AI, all those factories, usually they use either reactive maintenance, basically just repair when a machine breaks, or scheduled maintenance, which is called preventive maintenance, which simply means just check a machine every single month, no matter what happens. And both of those approaches are super inefficient, because if we go to reactive maintenance, it's about lost production time plus emergency repair costs. So let's say your machine produces 1000 cookies every single hour, and then each cookie will be sold for $1. It means that every single hour your revenues are $1,000, right? But let's say your machine breaks, and it breaks for 3 hours. You just lost $3,000, right? And for the scheduled maintenance, it means unnecessary spending on machines that are working fine. However, after AI, we only check machines when it's necessary. And obviously, the maintenance cost is much lower, and you have no more unplanned downtime, And obviously, you have both higher revenues and higher margins. Now, the main challenge with this project is that the machines need to be equipped with sensors, if it's not already the case at least. So those sensors will gather a type of data like temperature, vibration, maybe pressure, and so on. And most likely we need like a physical presence to assist in this task. And we need to collect the data produced by sensors. We also need to train AI models to learn what's the normal state of the machines. And then we need to alert the relevant people when it detects the machine is no more in its normal state. Guys, let me know in the comments if you are interested to know more about this, because I could do like an entire video where we go through a project from A to Z about this. And our fifth and last AI research and development project is about AI for call center automation. So it's basically ideal for businesses who manage large volumes of calls per day. And it makes sense for the calls where things that are discussed are not that complicated, It could be reminders, it could be customer service, like basic. It could be a virtual assistant service, or even lead qualification. The main challenge with this project is technical, because let's say you have a US call center that employs 1,000 people from the Philippines, and all of those people are paid $3 per hour. So if we convert that into minutes, it means 5 cents per minute. So for this system to make sense, it should be able to handle 100,000 of calls per month, and each call should cost at most 5 cents per minute. So from a technical point of view, it is insanely difficult, and I say it with all my experience developing complex AI research and development and also software engineering projects, because we need an AI with a realistic voice, right? We need some low latency, because we don't need people to wait before getting an answer. We also need the AI to be smart, meaning not only it needs to know what to say, what to respond, but also it needs to know when it's the AI's turn to speak, right? We need the scalable infrastructure that could handle on month A 10,000 calls, and in month B 500,000 calls, right? And also we need the high level of concurrency, can one phone number handle multiple conversations at the same time, and how many conversations can be handled? So basically this type of project, since it is super complex, it needs pilot tests, right, to determine the technical feasibility. So yeah, that was it, guys. I hope it was interesting. So if you want to learn more about this and you are interested, feel free to book a call with me via the Calendly link in the description. Cheers, guys.